Problem number 15, smallest integer divisible by k. Given a positive integer k, you need to find the length of the smallest positive integer n such that n is divisible by k and n only contains the digit 1. Return the length of n. If there is no such n, return -1. N may not fit in a 64-bit signed integer. Okay, given a positive integer, you need to find the length of the smallest integer n such that n is divisible by k and n only contains the digit 1. Okay, so maybe like if k is 11, no, 11 cannot be return the length of n. Okay. So n only contains the digit 1, so we can have like n will be 1 or 1 like 11, and find the length of the smallest positive integer n. What is the range of the k? At least 1. Okay. So if if k is 4, then we should return -1. I think any even number of k should return -1. Okay, and let's turn to the odd numbers. Okay, so if k is multiplied by 2 is 0, then return -1. I think it's every time I can I think the difficult part is how can we set the limit, like because for each we can start from n equals 1 with length 1, and can it be divided by k? If yes, then we'll return 1, but if no, we can add another digit and then the length will be 2, and we can try if it can be divisible by, if it can be divided by k. but at which length we should stop. Yeah, if k is okay, I think I have no idea. Okay, so we have to first know the module operations and so it says, yeah, like you can calculate the module k and see its results. If it can end up with 0, then it's the answer. But if it kind of turning into a cycle, like the results turning into the cycle, then we cannot get 0, and yes, we should return -1. Okay, so yeah, so keep module n with k, and every time we will add n with 1 by 1 digit, and yeah, so we will keep track of the moduled, not moduled results, and if it has 0, we can return the length, and if it goes into a cycle, like it goes into a cycle, then we can return -1. Okay, so we'll have mod result with I think set will be better. So we'll have a while loop. n will be started by at 1, while true mod equals n modded by k and if mod equals 0, then return the length of n. Else we should add the result mod result and okay, it's not, if it is not 0, then we should, we check else if mod results if current result is in mod results, then return -1. Else we will add n by one digit. Like n will be with the power of length n. Okay, maybe like we can try 1 if n is 1. If k is 1, n is 1, and modulo by k is 0, we can return 1. Okay, if k is 2, then it's 0, we will return -1. If k is 3, k is 3, then n modulo by 3 is mod is 3. Okay, so we'll have this else clause. If 3 is no, so we will have to mod plus add 3 inside, and we'll plus n to n will be 10 with the length 1, so 10 plus 10 is 11. Okay, now 11 modulo by 3 is 2. So 2 is not in the set, we'll add 2, and now length is 2 with the power 10 with the power of 2 is 100, so we will have 111, and for 111 modulo by 3, it's it's 0, so 0, then we will return 3. Okay. Oh. Maybe we can have a lens. Oh. I think there is some optimization. Okay, so it's based on the time complexity of this solution will be since the result of the current module, and that the result of n multiplied by k, it will have k kinds of results. K minus 1 kind. Okay, k times, because there is 0, then to k minus 1. So at most we will run k times, and it will be like so at most the while loop will run at most k times, so time complexity will be okay. So I think the TLE is due to this stuff, since every time it should do a lot of powers. So I will change. We don't have to calculate n, so we will change. We will have like module at first, it will be 0, and new module will be module multiplied by 10 plus 1. Yeah, so then we don't need this, and we maybe still need a length to calculate the length